Android engineer at Tumblr. And yeah, let's get started. So what is dependency injection? Why would you want to make it asynchronous? I'm not sure. I mean, dependency injection itself is kind of crazy. So this all kind of assumes that you know something about dependency injection already, and you know a little bit about how Dagger works, and Dagger 2 in particular. And we're going to build on Dagger 2 and make it asynchronous, and by looking at RxJava and Dagger Producers. Cool. So what is dependency injection? This is a really, really quick overview. Kind of like you're making a salad, and you take a cucumber and a tomato, and your salad depends on the cucumber and a tomato. I mean, what is a salad if you don't have those ingredients? Maybe you can make salad with other ingredients, whatever, but this is what the emoji looks like. It's kind of weird, though, because when you do when you have normal dependencies, without using dependency injection, you type new. You go into you have your chicken in this case, and you type new egg, or you do new poop. But actually, what dependency injection does is you invert that the dependency hierarchy. So if you think about it, it's like you're taking an egg and some poop, and you're making a chicken. I don't really know if that why that makes sense, but that is basically what you're doing. So it really depends whether or not it makes sense on exactly what you're doing. But in programming, it's just sort of like normal to us. So why dependency injection? Well, let's say you're trying to make sushi. You've got fish, you got rice. But let's say you want to change the fish to some tropical fish. There's a tropical fish emoji. I don't know what kind of fish it is. Maybe someone can tell me more. And you can still make sushi. Cool. So going right on to Dagger. So let's say you're trying to make sushi, and you're trying to put it into a bento box. I don't know if any of you know what a bento box is, but it's basically a bunch of like foods put together in a box, like a lunch box, and they sell it in Japan and whatever. But here I'm going to use the bento box to represent the activity, and the sushi to represent some sort of like dependency that activity needs. So here with Dagger, we've got a sushi module. We've got fish, we've got rice, and you've got the sushi that depends on the fish and the rice, and it creates a new piece of sushi. And so going back to that diagram before, here in our bento box activity, we're injecting a piece of sushi into our bento box. What's important to note here is, well, first of all, I'm using the Dagger and Android stuff that Ron probably talked about at his talk a little bit. So that's like the new thing in, I think, Dagger 2.11? Yeah. So that will make your life easier just using Dagger 2 normally. But what's important to note is that all your dependencies are created here before onCreate. So this is happening on the main thread before your layout is even displayed to the user. So if you have any sort of heavy dependencies, this is all those things are being created on the main thread before your user even sees your activity. And that's like not great, especially for an app like Tumblr, where we have a lot of dependencies, and we're injecting and creating all of them up front with the first time the user launches the app. And obviously, you inject these dependencies because you're going to do something with them, right? You shouldn't. So the best way to improve performance is just not inject dependencies you don't need. But you're here because you have these dependencies and you're trying to make them more performant. So here you can see it's creating the fish first, then the rice, then the sushi, then it can put it into the bento box, which is not performant. And it gets worse. like let's say we're trying to add a salad to our bento box, right? So now we have to create all of these things before we can display anything to the user. So one way of thinking about this, I mean, this is how bento boxes work, right? They all the ingredients and all the things are already created when you buy it. So one way around this is kind of like, I know I'm using all these food analogies, but you can create dependencies lazily, kind of like what a restaurant does. So you have sushi, and then you've got an empty plate to indicate, in our case, that we're going to have salad there. But if you were interested in eating the sushi first, then you can create the sushi first and leave that empty plate. And then when you ask for the salad, then the restaurant goes and makes the salad, and then you're waiting for it, and then eventually you'll get to eat your salad. Also, I don't know about you guys, but I tend to eat the salad last because, I don't know, I don't like salad. And if I'm still hungry, that's what I end up eating. Cool. So, what is asynchronous dependency injection? Well, instead of creating all those things that we just saw on the main thread, we want to create at least some of those dependencies, maybe even all of those dependencies, off the main thread. Here I call this a side thread. I thought I was being clever. I don't know. So one thing that's important to remember that, and this actually often trips me up, is at the end of the day, like you're probably going to end up delivering all these dependencies that you're creating back to another thread, and it's usually probably going to be the main thread. So it's important that to remember that even if you moved all your dependencies to another thread, your user is still waiting on these dependencies. Like, let's say you're doing a network request or something like that. Even if you created the OKHP or whatever library to do your network request off the main thread, like you haven't necessarily finished what you're trying to do just because you moved all your dependency off. These are dependencies that you're using. And so, I mean, obviously you're not creating dependencies that you're not using. So you need to use these dependencies. So really, when you measure performance, you're probably going to look at the entire goal from like starting from when the user opens the app to when not only when all the dependencies initialize, but when they finish doing whatever you want them to do. So the reason why I went on that little rant is, let's say it takes a little bit longer to create, say, sushi right now. The user is going to be waiting, is waiting on both the sushi and the salad, right? So let's say the sushi is being created on the main thread. The user isn't going to be happy because, like, there's just going to be a spinner or the app is going to be frozen, especially if you're doing the add inject like I was showing before, and nothing's going to be happening. But let's say the salad is created like on time, then like just because you moved that creation off the main thread, the user doesn't necessarily notice that performance benefit. Now the salad's created. Now the salad is just waiting for your main thread to finish before anything can be shown to the user. So another thing that could also happen is, let's say the salad takes too long to make and the sushi is finished early. Then you can in practice you can display the sushi and then the user can go and eat it or whatever, or they can do whatever they want to do. They can interact with the app, and they won't notice, or maybe they will notice if you have like some sort of spinner indicating it, but the salad isn't. isn't finished, and then when a salad is finished, you can update the UI. So my point with all of this is that you want to keep your main thread, whatever you're doing on the main thread, as quick as possible, so that's so you have the fastest sort of like time to interaction. And on the side threads, you want to do on the background threads, you want to do any sort of like slow operations, such as like say networking here. This antenna was the most networking related thing I could find. And even if you're showing a spinner to the user, I mean, that's something, as long as they can interact with the app, then I think they're a little bit more satisfied. And remember, when the goal here is to reduce the amount of time that the user perceives before they can say do whatever they're trying to do. So even by moving things off to the background thread, it's probable that you've reduced the absolute amount of time that is spent waiting, because you're using the other cores on the phone and things like that. So, been talking a lot about emojis and salads and sushi, and I don't know if you guys are all confused. So let's dive into some code. We're going to still stick with the same sort of analogy here with the food. So let's say you've got your salad module, you've got like your cucumber, your tomato, and so there's a normal, like pretty straightforward Dagger 2 implementation of the salad being injected into your bento box. So let's say you wanted to do it with this whole asynchronous dependency injection stuff with RxJava. Well, one way of doing it is to make it lazy, and then call get on the salad on another thread. So in this case, I've removed a little subscribe on for another thread. So this particular block of code is happening on whichever thread you're calling this, you're subscribing it on. But this is sort of this is one way of like now when it calls get, it's going to create that dependency graph off the main thread if you choose to. I don't know why you would do all of this if you didn't want to move it off to another thread. You could have just called get normally. And then you can run whatever method you want with the dependency. But the problem with doing it that way is that, first of all, lazy, doing it this way is that lazy will have a different instance per scope. So like, let's say you have like an activity scope, and say all of this entire block of code is in your activity. And then you start another activity and you do lazy salad, then it would create another instance. I'm just going to be looking at Ron to make sure that I've said everything correctly. I did try to run this, so I think I'm somewhat confident in what I'm saying. So also, you probably wouldn't want to like every single time you wanted to get a salad asynchronously, like write all this code. So another way of achieving this is to make your salad module have an observable as an observable. So you can take that block of that observable from callable, but this time your observable salad will now take a lazy salad, and then whichever thing subscribes to this observable will go and it will go and call get on the lazy salad, and that will actually cause the whole dependency graph to be evaluated, and then the salad will be created. So the benefit, obviously you're reducing the amount of code you're writing, reducing the amount of boilerplate by doing this, but also because this is a singleton, you would be able to reuse that instance across, like, say, different activities. And then you can call, like, you can subscribe to this multiple times and you would get the same instance. Also partially because, well, it also depends on what you mark the lazy salad as. It could be singleton or not singleton or whatever. So the way you use this is that you can still do add inject. Remember, we're just only using RxJava 2 here with Dagger 2. So you can do add inject on the observable salad and subscribe. Now I've specified that we're doing this on a computation scheduler. You should probably have your own, like, I don't know, dependency injection scheduler, but whatever. And then when that salad is created, it will be passed to this consumer, and you can do whatever you want. I don't know, salad swim. Cool. So another way of doing this that is part of Dagger is a thing called Dagger Producers, and the documentation says it's an extension to Dagger that implements asynchronous dependency injection. So I went over how to do asynchronous dependency injection with RxJava, so how is this different? Here, with Dagger 2, producers, they have a whole different set of annotations for what are called producer modules and like, I don't know if there's a verb for it, but I call it production or something like that, instead of provides. So here you have module maps to producer module, provides maps to produces, and that's all you have to change. And does the rest of the work for you, pretty much. But there's a bunch of other work you have to do to set that up. You have to create a new, in this case, I made a new app component. It depends, this app production component is going to depend on app component. You're probably going to want to do this because there are probably going to be dependencies that you're going to need in this new production component. And we're going to refer back to that salad module that we just modified. And the other thing we had to change is that we can no longer just get a salad. we have to wrap it in a thing called a listenable feature, and this is kind of similar to the observable in RxJava. This lets you, like, well, you can't get the salad immediately, but it will kick off the dependency graph to go and build a salad. So how do you use this listenable feature? Well, first you need some way of, like, you need to get the app production component. I have some code on GitHub that will show you how to do this in terms of where to put it. I guess there are many ways of holding on to the production component. So, and you probably also have an app component in your app already anyway, so you could probably do something similar. But so you get a hold of the app production component, and you do this thing where you do features, add callback, kind of similar to subscribing to an observable, and when that callback completes, you have your salad, and then you can do whatever you want with it. What's important to note is that you can also add the thread that the callback will be called on, kind of similar to observe on with RxJava, and that's something you can play around with to try to, like, eke out a little bit more of, like, of performance. But that comes back to the point I was trying to make earlier with, once you've created this thing, you're on the wrong thread, and you probably want to do something else on another thread. So that's something to keep in mind. Now that you're doing these things asynchronously, the thread that you're on matters. So in this case, I didn't add any specific thread, so the callback will be called on the main thread. So I skipped over something earlier. With your production component, you have to specify an executor module, and the real thing you have to specify is this annotation called @production, which specifies the thread that your dependencies will be created on. So I think this is like the default one that they show in the docs is this cache thread pool. So I'm not going to go into details, but basically it'll create multiple threads to create your dependencies on. And the great thing about this is that, well, in theory, you could have like 4 threads, and you can be creating all these things like the fish and the rice and the cucumber and tomato all at the same time. And then those dependencies can go, and once those are created, you can create your downstream dependencies. And then that can be used, So now you've basically collapsed what looked like, say, like 8 units, eight things being created serially down to like, here I guess they each have 2 dependencies. So now we're down to like 2 thing emoji units of time to get to your bento box. And this is something that Dagger Producers makes it a lot easier to do, and it's much harder to do in RxJava. So in RxJava, we had to go and specify the thread that the dependency is created on. So you can imagine that if the fish and the rice were both observable, in order to create the sushi, you need to be observing both observables. And there are ways of doing that. I think one of them is like observable dot like from latest. But basically, you're writing all the code to that's merging the work from different threads yourself. And I don't know, if you don't have a lot of dependencies, then it may be easier to do it that way. Especially, it is hard to migrate to Dagger Producers, and I'll show you why in a little bit. But RxJava may be easier to implement right off the bat. Cool. So we've been talking a lot about sushi. I moved to rice balls. That probably didn't make any sense to you. But we're gonna assume that rice balls are made from fish, rice, and cucumbers. Why? It will make sense in the next slide. So let's say you have this dependency, the cucumber here, that needs to cross the boundary. So before, on the left side, we were doing everything on the main thread, and on the right side with the salad, we're making the salad in the background thread, and some sort of like dependency injection creation thread, dependency thread. So what do you do if you need to cross that boundary? You have something that you need from the background thread, right? So this cucumber needs to makes its way to the main thread before the rice ball can be created. Well, the thing is, provides can't depend on produces, and that's one of the big constraints of Dagger Producers. And I hope, I'm just gonna point out the joke. The things on the bottom are produce. I thought it was really clever, but maybe not. So provides can't depend on produces, and that means if you want to move, say, like OKHP to a background thread, but in all over your activity code, you have add inject whatever service, like say for us, I guess it would be Tumblr service. You can't do it because your add inject requires app provides. So then now like you're kind of, well, now I have to move Tumblr service off to the background thread, and it's just like annoying. So there are a couple solutions to this. Either your app provides, you can move your Cucumber to the main thread, and then your background thread is in the background, so your user isn't worried about it. So it'll just wait for the Cucumber to be created before it can make the salad. But another thing you could do is that you can also move the Cucumber to the background thread, and then you can move the Cucumber. You can keep the Cucumber in the background thread, and then you can move the rice ball to the background thread also. So this has the downside of now the user is sort of waiting for this rice ball to be created, but since you don't have the problem where the main thread, the provides depends on produces, maybe you could show a spinner or something, and when it's ready, it can be delivered back to the main thread when it's finished. Cool. So I don't know if everyone got all of that. So there's some other kind of like, I don't know what to call them, but they're like clever little tricks that I found when implementing Dagger Producers at Tumblr. One of them is to sort of like abuse the listenable feature. And one way of doing this is that if you have, say, a logger interface, and let's say whatever activity you have needs a logger, but your logger is takes a long time to initialize. It depends on a lot of heavy dependencies. One thing you can do is create an alternative implementation. All it does is defer the logging by taking, say, the string here, and we're going to go and wait for the real logger to be created before logging. So basically, every single time you call log on this deferred logger, it will keep adding callbacks to this future, like a queue. And then when the real logger is created, it will go and log. It will go through the entire queue and then log all the things that you want it to log. You can do something similar with RxJava also, but I think it's a little bit, I don't know if it's trickier. It might be trickier. And this is also maybe a little bit too clever, but because your logger was sort of being created in a background thread, it has to be at produces and so on. Well, if you still want to inject your logger, you can create another module, a main thread module, where you go and grab the app production component and create. So this will give you a reference to that listenable feature that we need here. And then instead of returning the real logger, you return this deferred logger. And that's that's the really nice thing about writing dependency injection sort of with interfaces. So in theory correctly, is that you can do something like this where you go and wrap the real logger with this deferred logger. And another sort of semi-clever thing is so one thing that I encountered a lot when implementing Dagger Producers was that because I can no longer rely on add inject for say, let's go back to Tumblr service.
I had to go and first of all remove that, but then like there's so many fields that require the Tumblr service to be there, and one sort of like quick thing you could do is after you say change your Tumblr service to be lazy, you can also convert the listenable feature to a lazy sort of to conform to the lazy interface. And one of the big issues with listenable feature is that when you call get, it's going to throw these exceptions if something goes wrong. I've never actually seen these exceptions get thrown. I don't know if Ron has ever seen them, but we have Dagger Producers running in a production app right now, and I haven't seen them. But you have to catch them because they're checked exceptions, and one way around it is to go and catch them and conform them to the lazy interface, and then otherwise, like if you don't throw the exception, then you can get you have the object. But remember, in this instance, when you call get, this thing is being created on the main thread. So this is just for us. There's just a big stopgap until we can figure out some way of rewriting our entire architecture to not assume that our networking layer would be ready. Cool. So I went through all of that stuff, and the big question is, should you use asynchronous dependency injection? And the answer is probably not, because went through a lot of work to get this. I don't know. I want to say it took me like 2 or 3 months to do this, and we didn't get a lot of gains from it. Here are 3 reasons why not to use it. There's a lot of mental overhead and a lot of extra code you need in order to implement asynchronous DI. A lot of libraries that you use, like say a lot of analytics libraries, may not necessarily, like they just might init on the main thread, and it's just like, well, what am I gonna do? And also your dependency tree is likely to be deep. Your app isn't gonna be necessarily faster just because you created all these dependencies asynchronously. If all these dependencies, if like say one of your dependencies depends on another dependency, depends on another one, depends on another one, and that just basically means they need to be created serially. So then, kind of, well, what are you going to do about that? So here's one example. So we use Facebook's image loading library called Fresco. It depends on OKHP. Well, at least in our case, it doesn't have to. But we use OKHP, so we want Fresco to also use OKHP. So part of this library has a thing called simple draw-e view, which is just like its replacement for image view. But it requires Fresco to be initialized. And obviously, simple draw-e view is a view, so then we're gonna want to put it in our XML. So if you remember all the way back from one of the first few slides, if activity layout requires simple draw-e view, then that means Fresco must be initialized before your activity is laid out. So we can't do this asynchronous dependency injection thing, and now OKHP must be created before your layout is inflated, and then now your main thread is just blocked on OKHP. So there are ways of fixing this, and this is actually what we're looking into now, but it's just not going to be pretty, because I mean I would like to put image views in my layouts, otherwise we're going to have to go and put view stubs in, or we're going to have to put image views after Fresco is initialized on a background thread. So so Fresco would be initialized, and it's going to notify the main thread that it's ready, and then you can add your images to your screen, which is kind of weird, and also a lot of work. Cool. So that's very unfortunate. So the way I would sort of express what I've learned is that asynchronous dependency injection is a last resort. You're trying to squeeze the last 100 or 200 milliseconds out of your sort of activity startup time. But in all likelihood, like there's probably easier gains. It's probably going to be a lot easier to go and remove all dependencies that you don't need. Like go to your product manager and be like, do we really need 2 analytics libraries? You know, and there are probably other things you can look into first before you look into asynchronous dependency injection, just because you want to keep all your dependencies on activity creation or app creation. So cool. That's the end of my talk. And yeah, I mean, you can see the code that I've put up, and that's my Twitter.